Hello, hi everyone. We're Team Zeux, and this is our Sprint 1 walkthrough for the AR surgical playback prototype. My name is Hassan, and I acted as the project lead, focusing on the initial Unity setup and the MRTK XR rig, configuration, and fixing the UI assets. I'm working alongside with Bashar, who worked on the video slate and the timing logic. Isra, who handled the JSON dataset transformation, who she integrated with the 3D object movements, and Arvin, who built the playback slate, including the scroll and speed functions. Yeah. Um, in this video, we'll quickly walk through five things: our team and Sprint 1 goals, the problem context, and the solution, and also the live demo in Unity and what's next. The problem we're addressing is how to help surgeons and trainees review mitral valve surgeries in a more interactive way. Right now, they mostly rely on 2D videos and mental reconstruction. That makes it hard to go back to a specific moments in the procedure, understand tool motion in 3D, and slow things down or rewatch sections from different viewpoints. Our long-term vision is that AR digital twin of the surgery that you can replay, analyze, and also annotate. But for Sprint 1, the goal was deliberately small, prove we can create a working AR playback size, something that plays back a procedure, lets you scrub through time, and also how instrument moves relative to a target. Now Bashar will explain what we accomplished in Sprint 1 and how long the video logic works.
So the entire point of having Sprint One was to essentially create an MVP. Instead of having a complex Sprint One with a full-on human anatomy, we actually simplified it to have it like a cube and a needle for an instrument tip. So in summary, we have three major objects that are moving. Uh, a ball that represents the needle, a cube that represents the target region, a virtual screen that plays an MP4 video of the surgery itself. Um, my main focus was actually to develop the video slate and have it be the master time. Um, this means that the MP4 of the surgery, the timing of that will be dictating the timing for the entire scene, ensuring that the 3D objects stay perfectly in sync with the actual video of the surgery. From a feature perspective, in Sprint 1, we implemented a Unity scene with a ball, cube, and screen, a playback controller to play pause the motion, a timeline slider to scrub through time, and a speed control to speed up and speed down the playback. We also set up the environment that runs seamlessly on Unity uh, 2022.3.62 F2 using the XR rig setup Hassan configured. And essentially, you'll get to see this next with Arvin and Istra taking it away with our Sprint 1 increment in action.
Thank you, Bashar. So, Arvin and I are going to do the live demo. So in the scene, oh, I'm just going to wait. Okay, here. So, in the scene view, you can see three main objects. We have the ball, the cube, and the video screen, all grouped under the parent rig. So my contribution was integrating the JSON data into the movements. So the ball and the cube aren't moving just randomly. They're reading coordinates data from a JSON file that maps the timestamps of the video. That maps the like the objects to the timestamps of the video. So now we will enter the play mode so that we can show the interaction loop. I'll let Arvin walk you through the playback slate controls that he implemented.
All right. So we'll enter the play mode. So at the bottom of the screen, you can see that there's the slate I created, which includes the play, pause, scroll, and speed functions. So I'll first click play. And here you can see the ball and cube moving according to the JSON data Isra mentioned, while the MP4 video plays on the screen. I integrated the code to ensure these 3D objects respond immediately to the UI endpoints. I'll now press pause to freeze the motion. So what happens is the playback stops at the current timestamp, and both objects and the video stop together. I'll then use the scroll and scrub functionality. And here, while dragging the timeline slider, the ball and the cube jump to the exact pose defined in the code, and the video also updates instantly. This allows the trainee to scrub specifically to a key moment. I'll start the scenario again to demonstrate the speed function I added. So,
Just give it a second, let it load.
yeah.
And there you go.
All right, I'll start again by playing the scenario to demonstrate the speed function I added. So right now the playback speed is normal, and I'll increase the speed using the buttons. So now when we play it, you can see that both the objects and the video is playing a lot faster. So this lets the user skim through the parts of the procedure. We can also slow it down to get more of a fine-grained view of the motion. So finally, the environment itself has been set up using the MRTK XR rig. If I select the parent rig object in the hierarchy, I can move the entire simulation. This confirms that our playback slate and 3D objects functions correctly, regardless of where the user places the content in their physical room. And that concludes our core demo of the sprint. And I'll pass it back to Bashar and Hassan for the closing.
Thank you so much, Arvin. In conclusion, this was our sprint one. Our main goal was to prove that we could
Next
build
slide.
a working playback loop. To summarize, our sprint one, our main goal was to prove that we could build a working playback loop in AR using simple objects synchronized with a real surgical video, using the video as a master time source. We learned a lot about setting up Unity with MRTK and ensuring the JSON data aligns perfectly with the video frames. In Sprint 2, we plan to move closer to the vision of adding more realistic human anatomy and preparing for deployment on an actual AR device.
So thank you everyone for watching this Sprint 1 walkthrough. All of our code, including the playback slate logic, JSON parsers, and the rig is set up in the GitHub repository. Would appreciate any feedback or questions in the course forum. And thanks again from Team Zeux.